two functions that are inverses of each other will reflect across the line y is equal to x, this one here. This shows that each point that has an xy coordinate in a function has a matching point that is the reverse of those coordinates in its inverse function. So let's say we have a function here, f of x, this line. The inverse function reflects across the line y is equal to x. So this is the inverse function here. Now let's say in f of x we have a point -1, +3 here. If we reflect across y is equal to x, we see that we'll have the point 3, -1, the result of switching the original x and y. Let's say we have the point 0.7 on f of x. That means the inverse function will have the point 7.0. So we take the original x coordinate and we make it the new y coordinate for the inverse function. And we take the original y coordinate and we make it the x coordinate in the inverse function. Let's take a look at one more. Let's say we have -7.0 on f of x. That lets us know the inverse function will have the point 0, -7. So why is this important? This lets us know that if we are given a function f of x, we can graph the inverse by creating a table of values for f of x and then switching the points. And we know those resulting points exist on the inverse function. So let's walk through an example together. Graph the function and the inverse function f of x is equal to -3x plus 2. So what we want to do is first evaluate f of x with 5 different input values, and then we will record these x and y values in a table of values. And then we'll take these x and y values and reverse them to create a table for our inverse function. So let's evaluate the f function with 5 different input values. F of -2 is equal to -3 times -2, which is 6, plus 2, which is 8. So the x coordinate is -2 and the y coordinate is +8. F of -1 is equal to -3 times -1, which is +3, plus 2 is equal to 5. So the x coordinate is -1 and the y coordinate is 5. F of 0 is equal to -3 times 0, which is 0, plus 2 is equal to 2. So the x coordinate is 0 and the y coordinate is 2. F of 1 is equal to -3 times 1, which is -3, plus 2 is -1. So the x coordinate is +1 and the y coordinate is -1. And f of 2 is equal to -3 times 2, which is -6, plus 2 is -4. So the x coordinate is 2 and the y coordinate is -4. And now that we have a table of values for f of x, we can create a table of values for the inverse function. And we do so by switching each x, y in the ordered pairs of the original function. So you want to create a table for the inverse function. You have your x's and your y values. This is your table for the original function, f of x. This is the table for the inverse function. And now we take each of these ordered pairs and switch their x and y values. So -2, +8 becomes an x coordinate of +8 and a y coordinate of -2. -1, +5 becomes 5, -1. 0, 2 becomes 2, 0. 1, -1 becomes -1, +1. And +2, -4 becomes -4, +2. Now, for the original function, we'll be using -2 through +2. But based on the function provided, the y values will vary. So for the table for the inverse function, All of these points may not fit on the graph that we use. We just need a few points to sketch the graph. So don't worry if they all fit. We'll just be using 5 points each time just to standardize the process so we know what we want to do when we graph the inverse functions. Okay, so now that we've recorded the input and output values from step 3 in a table of values here, step 5 is to plot the points from the table of values for f of x and then draw a line through those points. So we have our table. We have our y is equal to x line, 45 degrees in quadrant 1 and quadrant 3. Our first point is -2, +8. Our second point is -1, +5. Our third point is 0, 2. Our fourth point is +1, -1. And our fifth point is +2, -4. And with these points, we can now draw a line through them to get a sketch of f of x. And now we take the table for the inverse function and plot those points. So here are the points for the inverse function. Now for this inverse function, the way that I drew f of x, these x coordinates actually do not fit within this coordinate plane. But these 2 points here do fit. And since this is a straight line, this will allow us to sketch the inverse function either way. So don't worry if for the inverse function you wind up with only a few points that fit on your graph. That's perfectly normal. You just need a few points in order to graph it. So we'll actually start with this point here. X coordinate of 2, y coordinate of 0. And then the next point is -1, +1. And with these 2 points alone, again, since it's a straight line, we can use these 2 points to sketch the inverse function. Now with the x and y present, it's a little bit hard to see that these 2 lines are reflecting across the y is equal to x line. So if I remove those, it's a little bit easier to see that they are reflecting across that line. So that is how you go about graphing the inverse function. Let's now have you try a few practice questions. Graph the function and the inverse function. Question number 1. F of x is equal to -2x + 1. Question number 2. G of x is equal to x cubed minus 1. And question number 3, h of x is equal to -x squared plus 2 for x is less than or equal to 0. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, we're given the function f of x is equal to -2x + 1. Step 1, evaluate f of x with 5 different input values. So we'll use -2 through +2 for our x's and record the x-y pairs in a table of values. F of -2 is equal to -2 times -2, which is +4. +4 plus 1 is equal to 5. So the x value is -2 and the y value is +5. F of -1 is equal to -2 times -1, which is +2. +2 plus 1 is equal to +3. So the x value is -1 and the y value is +3. F of 0 is equal to -2 times 0, which is 0. 0 plus 1 is equal to +1. So the x value is 0 and the y value is +1. F of 1 is equal to -2 times +1, which is -2. And -2 plus 1 is -1. So the x value is +1 and the y value is -1. And f of 2 is equal to -2 times 2, which is -4. And negative 4 plus 1 is equal to negative 3. So the x value is 2 and the y value is negative 3. And now that we have a table of values for f of x, we can create a table of values for the inverse function. So we want to switch each xy value in each ordered pair. And that will give us the ordered pair for our inverse function. So we create a table for the inverse function. And we take each ordered pair and switch the x and y's. So negative 2, positive 5 becomes positive 5, negative 2. Negative 1, positive 3 becomes positive 3, negative 1. 0, 1 becomes 1, 0. Positive 1, negative 1 becomes negative 1, positive 1. And positive 2, negative 3 becomes negative 3, positive 2. And now we have the tables for both functions, so we can begin graphing. So we want to start by plotting the points for f of x. So our first point is negative 2, positive 5. Our second point is negative 1, positive 3. Our third point is 0, positive 1. Our fourth point is positive 1, negative 1. And our fifth point is positive 2, negative 3. And now with these points, we can sketch f of x by drawing a line through these points. And now that we have f of x, we can begin sketching the inverse function. So we want to plot the points from the table with the inverse function. So our first point is positive 5, negative 2. Our second point is positive 3, negative 1. Our third point is positive 1, 0. Our fourth point is negative 1, positive 1. And our fifth point is negative 3, positive 2. And now with these points, we can sketch the inverse function. If I remove the coordinate plane, it's a bit easier to see that they are reflecting across y is equal to x. So that is how you would complete question number 1. Let's now have a look at question number 2. We're given the function g of x is equal to x cubed minus 1. So step 1, evaluate g of x with 5 different input values. G of negative 2 is equal to negative 2 cubed, which would be negative 8. And negative 8 minus 1 is equal to negative 9. So the x value is negative 2 and the y value is negative 9. G of negative 1 is equal to negative 1 cubed, which would be negative 1. And negative 1 minus 1 is equal to negative 2. So the x value is negative 1 and the y value is negative 2. G of 0 is equal to 0 cubed, which is 0. Minus 1 is equal to negative 1. So the x value is 0 and the y value is negative 1. G of 1 is equal to 1 cubed, which is 1. And 1 minus 1 is equal to 0. So the x value is 1 and the y value is 0. And g of 2 is equal to 2 cubed, which is 8. Minus 1 is equal to 7. So the x value is 2 and the y value is 7. And now, since we have a table of values for g of x, we want to create a table of values for the inverse function. And now we can fill in this table by switching each xy coordinate in the ordered pairs of g of x to create the ordered pairs for the inverse function over here. So negative 2, negative 9 becomes negative 9, negative 2. Negative 1, negative 2 becomes negative 2, negative 1. 0, negative 1 becomes negative 1, 0. 1, 0 becomes 0, 1. And 2, 7 becomes 7, 2. And now with these two table of values, we can begin graphing each of these functions. So we'll begin by graphing g of x and plotting these points on a coordinate plane. So this is our line for y is equal to x. And our first point is -2, -9. Our second point is -1, -2. Our third point is 0, -1. Our fourth point is 1, 0. And our fifth point is 2, +7. And now with these, we can sketch g of x. And now we want to take the table for the inverse function and graph these points. So we'll begin with -9, -2. The next point is -2, -1. The next point is -1, 0. The next point is 0, 1. And the fifth point is 7, 2. And with these points, when we draw a line through them, we have the inverse function. And we see that our two functions are symmetrical across the line y is equal to x. So that is how we go about sketching g of x and its inverse function. Let's now have a look at question number 3. We are given h of x is equal to -x squared plus 2, and we restricted the domain to x is less than or equal to 0. So step 1, we want to evaluate h of x with 5 different input values. So we'll start at 0 and work our way down. H of 0 is equal to -0 squared, which is 0, plus 2 is equal to +2. So the x value is 0 and the y value is +2. H of -1 is equal. So here we have -1 squared, which is +1. And -1 times +1 is -1. -1 plus 2 is +1. So the x value is -1 and the y value is +1. H of -2 is equal to -2 squared is +4. So -1 times +4 is -4. And -4 plus 2 is equal to -2. So the x value is -2 and the y value is -2. H of -3 is equal to -3 squared, which is +9. -1 times +9 will give us -9 here. And -9 plus 2 is equal to -7. So the x value is -3 and the y value is -7. And h of -4 is equal to -4 squared would give us 16 here. And -1 times 16 gives us -16. -16 plus 2 is equal to -14. So we have -4, -14. And now, since we have a table of values for h of x, we can create a table of values for the inverse function. So we want to take the x, y values in each of the ordered pairs for h of x and switch them to create the table of values for the inverse function. So 0, +2 becomes +2, 0. -1, +1 becomes +1, -1. -2, -2 remains -2, -2. -3, -7 becomes -7, -3. And -4, -14 becomes -14, -4. And now we can begin sketching h of x and its inverse function. So we'll begin by plotting the points from h of x. So we have our coordinate plane with our line y is equal to x. And the first point is 0, +2. The second point is -1, +1. The third point is -2, -2. The fourth point is -3, -7. And -14 will actually take us off of the screen based on the scale that I'm using for the XY. But just these 4 points is fine. We have enough here to be able to sketch h of x by drawing a line through those points. So this is -x², an upside down parabola, plus 2. So it starts up here at 2. And now we take a look at the table for the inverse function, and we plot these points. Our first point is 2, 0. Our second point is +1, -1. Our third point is -2, -2. And our fourth point is -7, -3. -14, -4 would take us off of the screen, but having just these 4 points is fine. So if we draw a line through these points, we have the graph of our inverse function. And we see that our function and the inverse function reflect across y is equal to x.